First of all, I would like to welcome you all. So today we will go with a short revision. Yesterday, what we saw, the features of Java. So as you know, there are the different types of features which are used to in Java application. Why we are seeing this feature? Because what makes the Java different from the other programming language that we will be seeing by the features of Java only. Okay. So first feature was the platform independence. How it is the platform independence means that it works on the all the devices because we are sharing the byte codes. We are not sharing the main source file. Okay, so due to which the byte code we are sharing, then it is more concise and easable to us to work on the another devices. As it increases the ability to run on any device without the changes, then it makes our Java program as a platform independence. Okay. Uh, then what was the next point here we saw? That was the probability or portability. Sorry, portability. What the portability means here? The easily movable. What the easily movable means here? We share the byte codes and stay on the same for the every platform. Means we our byte code is same because we don't change our byte codes. We say share our the dot class file. Dot class file to whichever the another computer or another devices we are using, and we are not changing in that, and we are transferring from one device to another devices or the multiple devices. So it is a easily shareable from one device to another, or you can say it is a transportable also. So that's why it is known as a portable. This feature makes our program as a portable here. Okay. Then next point what we saw here is ORA. What this ORA means? Write once and run anywhere. Write once and run anywhere in the sense here we are writing the program once only on a particular device. Okay, and your code is being written one, and it is shared to the multiple devices or the all devices which you want to work with using a JVM. What happens here is after sharing on the another devices, the JVM should be installed in the another devices. Okay, it is a mandatory, so the our program will be run easily because we are what we are sharing is the interpreted programming language file. Okay, so we are not sharing our main source file or the high level language file. Okay, because we are sharing our code in a interpreted level language. So the JVM is required. Why it is required? Because it has the ability to convert the interpreted language into the machine level language and make our program as a successfully execution. Okay, so we can get the output on the whichever the devices we are aiming for or they expecting for. So here we see write your Java program on the any computer and they convert it to the bytecodes. Okay, then use the bytecode to run on your program on any devices. It indirectly says the what we saw here. Okay, so it is the concept of ORA. Then next what we saw is we saw the architectural neutral. What the architectural neutral means here is the configurations of the system does not depends here because our Java program is directly executable on the any configuration. Okay, it does not depends upon the architecture of the computer. Means the hardware or whatever the RAM is, the whatever the processor is, or what is the memory size. It does not depends upon it because it is a platform independence as well as the ORA, which supports our Java and makes Java as a more simple. Okay, easy to understandable. So that's why it is a architecture neutral where the Java programs are turned into the bytecodes and which works on any devices. How does it work? As I told that the JVM, Java Virtual Machine, which adjusts the bytecode to your devices. Means a particular whichever the device you want to run, the JVM will adjust that to the that devices. It is a small example we saw that how it is directly in the real life it is applicable is like a USB drive. Okay, as we use the USB to the any system or the any devices We just plug in and plug out, and it is a universally applicable to any devices. The same way, our Java is a architectural neutral, means it is does not depend on the whichever the devices is, it will support to the all the devices. And rather than this, we can say the Java has a more features such as the simplicity. That is a simplicity. How the simplicity means, the program code is a very simple to understand, because high level we are writing the program in the high level language, and it is a mainly used with a basic English also. So it is a simplest language and easily to understand from everyone perspective. Okay, and it increases the security. You can also say the security increases. It supports the security. How does it support the security? As you saw yesterday, that when we share the file in the bytecode, if the hacker tries to hack the file, then he will get the file into the bytecodes. Bytecodes in the sense means the alphanumerical characters, the program file in the alphanumerical characters. So that's why he will not easily be understandable, or he cannot do the any changes or the any malpractice with the our source file. So that's why it is a secure platform to use the Java. Okay. So these were the main features we saw yesterday. And now we will see with our next topic. What is the next topic is the architecture of the Java. Okay. Let's move on to the next topic, architecture of the Java. So what does this architecture in the sense means here is the blueprint behind the Java problem. Means how the execution works here. Means how does the Java means back in the backend, what the Java runs and how it executes, what all the data or what all the files or what all the setup we have to do for the working the Java in the devices that we will see here. Okay. First is the JVM. We are repeating that multiple times that JVM will convert the code into that. So what is JVM now? We'll see here. See, JVM is the heart of Java. It is the main part of the Java. As the human body have a heart as a main part, because human cannot live without the heart. So JVM also is also a heart of a Java, which cannot be have a without JVM. The Java is nothing. Okay, so that's why we call it as a JVM as a heart of Java. Because the reason behind is that Java can run on the different devices without any changes by using only the JVM. JVM has the ability to change your code from the interpreted language to the machine level language. It acts as a smart bridge between the CR. It acts as a smart bridge between the Java programs and the computer devices, because it has the ability to convert the code into the machine level. Okay, interpreted level language code into the machine level language. So the JVM is the must and should in the Java. Without JVM, the Java is not able to work here. Okay. Now, so let's move to the next. How does it the JVM works? Okay. Here, see, the Java code is compiled into the bytecode. That is the dot class file. Okay, not directly into the machine code. As we are saying from the last day in the previous classes also, we say that how the code is converted from the high level language to the interpreted level language and then machine level language. It is not a direct process where the high level language is converted to the machine level language. Okay. So therefore, the JVM reads this bytecode and translates into the machine instructions based on the operating system. Okay. Means whichever the device operating system you have, it will convert or the convert or translate the code. Translate the code in a machine instructions based on your operating system. If we are going with the Windows, then it will convert the code as a into the Windows level operating system to understand easily by the Windows, or else it will go for the iOS in the sense as the Mac. Okay, iOS, or in the sense it will go for the Android also. Okay, means of Linux, Android, Ubuntu, multiple operating systems we have. So whichever the system operating system is based, the JVM will support and translate that high level code into the machine interpreted level code into the machine level code. Only it is possible with the JVM. Okay. So that's why the JVM is used to read the bytecode. And this ensures that the Java application can run anywhere as long as the JVM is installed. In whichever the device the JVM will be installed, it will ensure that the Java code is executable properly. So that is the basic, that is the main work here of the JVM. So the JVM is must and should, and it is also known as, therefore it is known as the art of the Java. Okay, art of the Java. Now in the real life analog, so just you think about Java as a skilled translator. Means you just think that we have a Google translator, means from English to Hindi, Telugu, Kannada, whichever the language you are choosing, it will translate the same way. So the JVM, you also take as JVM as a example, the skilled translator. Here, you can imagine that book is written in the universal language. That is also known as a bytecode. Now, you take that example as a, if you are having one book and which has a alphanumerically printed language, means you cannot read it. Then that book is given to the JVM, so to translate it to the different language based on the its operating system. See, so JVM translates it into the different languages based where it is being read. Means if you are reading in India, then it will go with Hindi, English, or something, whichever the languages used in India. It will in Japan, then it will go for the Japanese language, or then Germany, it will go for Spanish and German language, because it depends on the operating system. The same way, it depends upon the book where you are reading. So the bytecode will be converted according to the operating system. Same the real time what you can take here, the real time life analog. We can compare the example of JVM as a book translator. Means a person who can translate the book and make a explanation. So if you are telling in, please explain in the Hindi, then the book will be translated and explained into the Hindi. And if you are you are a Japanese or you are Chinese, if you are, so then you will tell us make the book and convert into and translate into a Chinese language. Then it will convert the JVM will convert your book into the Japanese or Chinese language. The same way, the JVM will convert here the interpreted level language to the machine level language based on the operating system. As the book was converted based on the countries, means the whichever the language you are requesting, the same way it will check with the operating system, whichever the operating system is being used in there, level only it will convert. And it's that understanding operating system, it will make and it will be converted the machine level instructions. Okay. So this was the basic of the whichever you should must know about the JVM. Now here is a small example which is also a normal program. Okay, a public class JVM test, and here is the main method public static void main string of args system.out JVM makes a Java portable. Okay, now we saw the feature. Okay, which feature we saw? That portability. What the JVM makes here is the portability. Means how, because based on the operating system, it is converting the interpreted level language or a bytecode language into the machine level languages. So it makes a portability, means it can transfer from whichever the devices from one system to one devices to another devices. It does not matter the which operating system the device is having, because the JVM will support and it will adjust it translation or the interpreted level bytecodes to the machine level language based on the operating system. So it does not depend on the devices. The JVM does not see the whichever the device is, because the portability helps here code the translate the code from the interpreter level to the machine. Okay. So the next is the here one more the line, basic important line. Compile with this as a Java suite. We saw that in the command prompt, we were executing our program using the Java C and file name to compile it. Okay, Java C here it means Java compiler. C is a compiler. Okay, result of the bytecode will be run in platform. It will show after typing this with the file name, it will give you if any compilation events are there, then it will be shown on the command prompt. Okay. The next feature we do which is the architecture. In the architecture we have the Java runtime environment, JRE, the executor. As the JVM was the part of the Java, it is the executor of the Java. What this executor means here is this JRE helps to provide you the environment, the runtime environment, where the Java JVM can run the code it provides you an environment where the Java executes the code. Okay, see here. JR is a complete package that provides everything required to run a Java application smoothly. Means whichever the files, whichever the requirements, the devices will be applicable with the Java, that all will be provided by the JRE. The JRE itself, the name itself says as a Java runtime environment. Means it will provide you the environment to run the Java. Okay. See, environment to run the Java. You can read it like this. Java runtime environment, JRE. See, it acts as a bridge between the Java programs and the system. Same as a JVM. Ensuring the function properly, and inside JRE you will find the JVM. Yeah, in the JRE you will find a JVM, which translates the bytecode into the machine code, along with the collection of the essential libraries. What these essential libraries are the in the essential libraries and files are the means whichever the files or the libraries which are required to run a particular program in a JVM. By means if JVM is executing any particular program, the whichever the files or the libraries are required, that will be fulfilled by the JRE. See the JRE. Okay, in JRE the JVM is present. Okay, repeatedly. Support the execution. Without the JRE, the Java programs will not have an environment. They need to run the efficient. Okay. See what's inside the JRE. Java runtime environment. See, that is a JVM that translates the executes the code into the bytecode. This is the first thing in the JRE. Then what is next? Java standard libraries means which provides the essential classes like file handling, networking, and utilities. Means whichever the things are required to execute the program as correctly, these are the provided by the standard library, Java standard library. Then supporting files. Supporting files are the additional tools needed for the execution. For execution, whichever the files are removed, required that will be completed by the JRE. Okay. So why JRE is important? If the JVM is a translator, the JRE is the entire setup required for running the Java program. Okay, without JRE, you cannot execute the Java application. It directly shows that if the JVM wants to execute, the JRE is required. Inside the JRE, it is a JVM who is executing the code. JRE is the environment provider or the space provider in the devices. Okay, keep it in mind. Then analog, here the analog is the means real-time example you can check here. See, think your JRE is a full occupied kitchen. Okay, means how the kitchen is there, full occupied means whatever the materials, space, the whatever the requirements are there in the kitchen, all is fulfilled and there is available in the kitchen. That is compared as a JRE. How? See, JVM is a chef. What the JVM is a? JVM is a chef. If in kitchen there is a chef, he will take out the things. Means from the kitchen, the chef will take the things whichever he is required. Okay, to make a food. If suppose if you want to make a anything like a pizza or something, if you want to make, then chef will take out the things as a whichever they require from the kitchens. Suppose first you will take out the pan, or whatever the floor you need, floor you will take, water you will take, then oven, whatever the requirements are there, chili flakes and something, you will take out from the kitchen, and you will make the process or start the preparing that. Same way, here is the JRE. JRE is what? It is a kitchen. And JVM is what? It is a chef. Chef. It's the but the JRE provides all the essential tools as the means as available in the kitchen. The JRE is the kitchen. So everything is available in the JRE. Same way, everything is available in the kitchen. Same way, the JRE is also available. See, ingredients, stew, then utensils to make the delicious meal. Java program execution. Then JVM will take out the things from the kitchen. It's like a JRE. From JRE, all the requirement files are there for the executing the program. Okay. If we are making here pizza, from the chef perspective, if chef is taking out the things from the kitchen, whichever the ingredients, then stove and the utensils is needed for making the pizza in kitchen, in the same way, Java virtual machine means the JVM will take out the things from the JRE as a whichever the required files and the libraries are required to execute the program. It will take out from the JRE. Because the JRE is the full occupied kitchen. Okay, here. The full occupied kitchen like a JRE. So it is having all the standard essential libraries also and the essential tools which were required, the file supporting files. Okay. Then the next third feature or the architecture main thing is the JDK. JDK. What the JDK here is? The JDK is a Java development kit. The Java development kit, the creator. What it is? It is a creator. Yeah. See, JDK is a creator. JDK is a creator. Just I will make it proper. Just a second. See, JDK is a creator. And here JRE, capital JRE. Yeah, JRE is a executor. And JVM is a by default it copy pasting. Okay. Yeah. Sorry for that. Yeah. What is the JDK? JDK is a creator. JRE is a executor. And JVM. The JVM is a heart. Okay. Heart of the Java. Keep it in mind. If one of these thing is not there, then the Java will be not executed. The main basic here is the JDK. We are installing the JDK, okay, first of all. If we are installing a Java, whatever they have, Java development kit we are installing. Inside that, it is the JRE available. Inside that, the JVM is available. What JDK is? See, the JDK is where the Java programs are written, compiled, and tested before being run. It includes the everything in the JRE, yeah, plus additional tools and the for development. See, what are the key components of the JDK? Are the compiler, Java compiler, which converts the code into the bytecode. It is present in the JDK. Then debugger helps to find and the fix the error. In Eclipse, we find that while we are typing the syntax or something, we made a mistake, then it will show you the errors. Okay, which is the yeah, that is the debugger here only. See, helps to find and fix the error. Then libraries. What are the libraries? Where the libraries are the pre-written code to speed up the development. Means whichever they installed, whatever the requirements, files or execution, whatever they require for the execution, that are the presents in the libraries. That is present in the JDK and the JRE, Java Runtime Environment. Since the JDK includes the JRE, Java programs can execute it after the compilation. I will show you more concision in the proper way. Just in further way, I will show you. Till that, are you clear with these 3 points? Okay. How these three works here? Together code. Compile to the bytecode and then execute. See here. We'll see here. I will make it to minimize. Is it visible? See. Next, if we do, here is the Java file or the source file which we are writing in the high level language. Okay, whichever the hello world program if you are writing, that is we are writing here. Okay, see, then if after next compiling, what will be the process here? We will start the compiling. After compiling, what we will get here is a dot class file or the bytecode file. Okay, after saving and compiling, we will get a dot class file. Then after dot class file, next there is the Java runtime environment, which will load the class. Okay, the class loader. It will load the class into the memory. Then a bytecode verifier. Means whichever this bytecode is provided, is it correct or not? It will check. Then in further, it will see here is a Java virtual machine, JVM. It will give to the JVM just in the time compiler. Once in this particular time, it will be compiled. Then the code will be given to the JVM. Why? Because the code now from here, the high level language, see the code is into the high level language. And here the code is into the interpreted level language. Now, is it possible to directly execute or get the output by the this dot file? No, no. So that's why after the JRE, it will work. Then the class will be loaded. Means whatever the public class program we provide. No, for example, the public class program that will be loaded onto the memory, and this bytecode will be verified here. Okay, it will be verified. Then that bytecode will be given to the JVM. Why? From the interpreted level language, because it will convert to the machine level language. So therefore, see next we will see here. What the next? After that, see here. Next file. See the Java compiler, the JVM, the Java virtual machine. It will give us the executable code. Depends upon the operating system. If it is a Windows operating system or the Linux operating system or Mac operating system, whichever the operating system it will be executed according to that operating system. See now, and the execution output will be on the console. That is the full architecture of the Java. Okay, is it clear? We will see the solve this.